Hey there, welcome to Accelerated Math 3 and welcome to this lesson on key features of a rational function of its graph. What we're going to do in this lesson is look at a rational function and then we'll talk about some key features or the key features that you've explored before of the graph. All right, so let's go ahead and first introduce the rational function. And here is an image of a rational function. And a rational function is a weird looking graph. It has two pieces. One of the pieces starts on the left-hand side and it starts way out here and it kind of flattens out and then it kind of curls down and it's gonna shoot straight down there. So that's one piece of a rational function. The second piece picks back up on the other side of this dashed line, okay, and it starts maybe way up here, okay, right, and then it's going to curve down here and it's going to keep going, keep going, keep going. Oh, it's really ugly. It's going to keep going. I don't know if that's any better. And it's going to flatten out towards this dashed line, which will keep going on this way forever. This is a rational function, okay? And the first key feature that we're going to talk about is a zero. Very, very easy. It is pictured here. Here is a zero. And a zero is an x value. Again, it's the x value that just makes the function zero. So in this case, hey, the function intersects the x-axis, right, which makes it a zero. At the location 2. So the 0 is 2. The other thing I want to talk about with rational functions is asymptotes. Again, that word asymptote. Can you say that? Asymptote. Okay, you can say asymptote if you prefer that, but I'll be saying asymptote. And an asymptote is a line that the graph of a function approaches. It gets really, 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 really close to it, but it will never, ever, 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 ever touch it. Okay, and if I go back to this graph, right, you'll see I kind of extended that asymptote and I extended this line, and it'll get really, really, really close to. We can explore it on Desmos, right, and you can go over and you can say, ha, the function touches the asymptote here. And then I'll zoom in, I'll zoom in, I'll zoom in, and you'll see a gap, right? It will never, ever, ever touch it, okay? All right, so that's an asymptote. Now, rational functions have two asymptotes. They have a vertical asymptote and a horizontal asymptote. How do we name them? Well, we name them with the convention of how we name straight lines. So a vertical asymptote, it's going to intersect the x-axis, and you can see it here, and that occurs at -4. Okay, so since it intersects the x-axis at -4, we name it x equals -4. Super easy, right? Okay, I'm going to go ahead and do the same thing with the horizontal asymptote. Hey, it intersects the y-axis here, okay? Never intersects the x-axis, only the y-axis, and it does so at the value -2. So we name that straight line y equals -2. Very, very simple. Now, you'll notice this the asymptotes contained here are dashed lines. They're always dashed lines. So when you graph, and yes, you're going to have to graph, you will graph them as dashed lines, okay? All right, let's go ahead and look at an example. So here they want us to determine the key features for this rational function. So we'll start off with a 0, and you can see that the graph touches the 0 right here. Okay, so what's that x value? Well, the x value is 0. So I'm going to go ahead and I'm going to name it 0. It has a 0 at 0. And again, you were just using the x value, okay? All right, now I want to go ahead and I want to label my vertical asymptote. Well, my vertical asymptote, okay, occurs right here at 1, 2, 3. So it intersects the x-axis here at 3. So that is going to be x equals 3. Okay, how about the horizontal asymptote? Well, the horizontal asymptote intersects the y-axis here at 2. That's 2, so that is y equals 2. Very straightforward. Here's example 2. Okay, what is the 0? Well, I'm going to look for my x-intercept, and there are none. So we're going to say that the zeros occur at, you can say non-applicable, you can say there are none. You can say none. N-O-N-E, not N-U-N. Okay? Whatever floats your boat. Well, not whatever. Just make sure you say there's none. Okay. Next, vertical asymptote. Well, my vertical asymptote, hey, intersects the x-axis here at -4. So I'm going to say x equals -4. All right, what about my horizontal asymptote? Where the heck is that horizontal asymptote? It's not shown here, but you can kind of see that this is on top of the x-axis, okay? And that would intersect the y-axis here at 0, right? That's at 0. So I'm going to say y equals 0. Okay, straightforward. All right, I want you to go ahead and practice. Here is the last example in your notes. Please make sure, I hope it was clear. I kind of labeled them here, example 1, example 2. In your notes, I don't think they'll be labeled that way, but just keep track of that because we're going to be going back and forth to those same problems. Okay, so go ahead, pause the video, try this one. All right, hopefully you paused. Here are the answers. The 0 is at 3. The vertical asymptote is x equals 2, and horizontal is y equals -2. Okay, next, we are going to talk about domain and range. These are not new words to you, but the asymptotes kind of disrupts our domain and range, and so we'll look at that. I want you to remember that the domain is all of the input values that you drop into a function, also known as your x values, right? The range are your outputs. When you put a number in, okay, what do I get out? Well, that's your range, okay, and those are your y values. We're going to be working with domain and range in inequality form. Okay, shown here. So these are inequalities as well as interval. And that is shown here. You do need to remember, right, and I'm going to make this a note here. So parentheses, these exclude the values, and then brackets, these include the brackets. So I would add those to your notes. And remember to, we use parentheses whenever we use an infinity sign as well. Okay, so let's go ahead and look at some examples. And I want to give you guys a trick for this. Okay, what we're going to do with our asymptote, and actually you already have this kind of labeled, our x asymptote, or our vertical asymptote that intersects the x-axis is located here at 3, right? So I'm going to go ahead and highlight, these are all of my x values, or my domain values, right? And it takes a break here at 3. So this is all of the values, x is less than 3, and then again it picks up after 3, after my vertical asymptote, and continues on this way. So those are all the values, x is greater than 3. So my domain is x is greater than 3, or x is less than 3, okay? Now, how would that be as an interval? Well, I start out all the way to the left at -infinity, and I go up until 3. Now, do I include 3? No, there's an asymptote there. You can't touch the asymptote. Can't touch this. Right? I know, lame. Okay, so parenthesis. Okay, not closed, it's open. All right, union. I'm going to open another parenthesis. Okay, at 3, and then I'm going to go all the way to +infinity. All right, so that is your interval notation. Next, I'm going to go ahead and do range. Range are my y values. My y values. So I'm going to draw my y values. Drawing. Oh, and then I'm interrupted here at this value, which is 2. Is it 2? 1, 2, it is 2. Okay, 2. So I'm interrupted there. So that is, all these values are y is less than 2. Okay, and I'm going to pick back up after 2. I'm going to go on forever. Okay, y is greater than 2, all the way to heaven. Okay. So y is less than 2, or y is greater than 2. Now, how do I write that as an interval? Well, I start out at -infinity down here, all the way to 2. Okay, parentheses around both of those. Union 2 to +infinity. There you have it. All right, here's another example. We'll do this again. Okay, so what is the domain? All right, well, I'm going to color my domain since I'm new at this. Well, I'm not new at this. You're new at this. We're new at this. We're coloring. Isn't life great? Ah, asymptote. Okay, so I'm taking a break here. My asymptote is at -4. All right, so x is less than -4. That's this piece. Okay, and then it picks back up and it goes on forever to the right, which is x is greater than -4. X is greater than -4. Okay. All right, interval, that is -infinity to -4. Union, -4 to infinity and beyond. I know you were waiting for that. You were just waiting. Okay, and then the other one, my range. I'm going to go ahead and color my range. Here's my y-axis. Okay, so -infinity. Okay, up until, oh, okay, here's my, remember this is that weird one. Our asymptote is at 0. So I have an asymptote here, okay, at 0. So that would be -infinity to 0. All right, and I'm going to keep going all the way up. Okay, union, and I hope you get the picture. Okay, and that is, y is less than 0 or y is greater than 0. Did I make an error on my last page? No, I didn't. I used y. Life is good. Okay. All right, so that's domain and range. Here is a practice problem. Please pause the video on example 3. I want you to go ahead and try this one. All right, so hopefully you pause the video, and here is the solution. Okay, so there you go. We have a break at 2 for our x values, and then a break at -2 for our y values. Okay, next we are going to go ahead and talk about increasing and decreasing. And this is very, very simple. A function is increasing when the function values increase as the values increase. Plain and simple, if my graph is going up from left to right, it's increasing, right? If my function values are decreasing when my x values are increasing, then my function is decreasing, right? If it's going down, decreasing. If it's going up, increase, you know. All right, so here are 2 visual examples, and you can go ahead and see this. And again, the tricky thing with rational functions is there's 2 pieces, and that confuses people. Don't let it confuse you. So here's my graph. Okay, and I'm just I'll make it red so you can easily see it. So I'm gonna put some dots. Okay, or what are my function values doing? Are they going up or are they going down? They're going up. Good, right? Okay, now I'm gonna go down here. Just forget I had to lift my pencil. We'll talk about discontinuities later, right? Lifting of the pencil. Okay, now I'm down here. Now keep dotting as I go left to right. What are they doing? Are they going up or going down? They're going up, right? Okay, good. So then is it increasing or decreasing? It's increasing. Plain and simple. All right, so look at this one. Here, my function values they're going down. Yes, I know they're going down, right? So, okay, now I'm going to go, but over here, I had to go up. You just lifted your pencil. You weren't going up, right? You just lifted your pencil. Now what are the function values doing? We're going down. Yes. So what is that? That's decreasing. Decreasing. Plain and simple. Rational functions are either only increasing or decreasing. Okay? And just look at one piece and you can tell. I look at this piece here. Hey, they're going up. I know it's increasing. Hey, look here. Right? They're going down. Decreasing. Okay? All right. So all right, what I want to do, okay, next we're going to talk about end behavior, and this is arguably the trickiest kind of part of the lesson, and well, I'll go ahead and go over an example. All right, so here's our definition. For a rational function, end behavior is the mathematical description of the value the function approaches as x approaches -infinity or +infinity and any other value of the vertical asymptote. So with rational functions, we end up having 4 pieces. Okay, I'll label this number 1. Right, here's number 1. Okay, then I have piece number 2, which is down here. Number 2. Okay, and then here is number 3. And then we bust out purple. Number 4. Oh, I forgot my labeling over here. 3. 2, 1, lift off. Okay, so we have 4 end behaviors, and we have to go ahead and describe those. Remember, end behavior, first you describe what's happening as I go left to right. So as x goes, where's x going? Is it going all the way to negative infinity? Is it going all the way to positive infinity? Then the second piece you describe, okay, what's happening to the y values? Does it go up or does it go down? Now, asymptotes complicate this, and we'll talk about asymptotes. But first I wanted to look at example 1. So example 1, it says here, as x approaches negative infinity. Okay, so this is, okay, so let me get a different color. Ooh, I like this color. Okay, so look, here's my function values, and my function values are approaching, I'm making dots, they're approaching negative infinity. And I can keep going this way forever, literally, okay, to negative infinity. I'm going this way. Now, what are the y values? What's the height of the function doing as I get closer and closer and closer to this asymptote? Remember, I have this asymptote here that's going to limit me, okay? And that asymptote, right, is located in this case at -2. So the function values are approaching -2. All right, what about that little negative right here? Okay, so here is how we denote, is it approaching the asymptote from the bottom or the top or left or right? Okay, and I'm going to go ahead and write this down. So as x approaches negative infinity, the function approaches -2 from the bottom. So we use a negative superscript. Okay, you just add on, it's almost like an exponent, negative. Okay, that's how you say from the bottom. All right. I'm going to go ahead and cover number 2 next. Okay, so it says as x approaches -4, so let me erase this right here real quick. Okay, so as x approaches this way, so my x values, what are my x values getting closer? Here they're at -5, and they're getting closer and closer and closer and closer to what value? Well, they're getting closer and closer to -4. So as x, I want this to be green, as x approaches -4. Okay, now what side of the asymptote is it approaching from? Well, it's approaching from the left. Okay, so that's why I use this. Here's the left, that means the left. Okay, so if it's a negative, it means bottom, if we're talking about vertical, and if we're talking about horizontal, we talk left or right. Okay, let me go ahead and look at the next example. Okay, here's my function. I'm approaching this third end behavior here, where I have this arrow. My x values are approaching, again, they're getting closer and closer and closer to this asymptote at -4, right? So I can say here, as x approaches -4 from the right. Okay, and when I say from the right, when I want to describe that, I use a little plus sign right there. Okay, so that's what that plus sign means. All right, next I want to go ahead, I want to do piece 4. Okay, so my x values are going out this way, and they're going towards positive infinity, right? That makes sense. Okay, now what are my function values doing? What's the height of my function? Well, my function's getting closer and closer and closer to -2 again, but this time it's doing it from the top. So as x approaches positive infinity, the function values are approaching -2 from the top, right? And that little plus sign there, that's how we say top in mathematics. Okay, so I just wanted to explain those negatives and positives like superscripts. Sorry that kind of took a while. We're going to move much faster now, but that's kind of the explanation and hopefully some color coordination to make it clear. All right, so here is example 1. So we're going back to the first example. And we want to know, is f of x increasing or decreasing? So let's go ahead and look at this. My function values are going down. So since they're going down, it is decreasing. My function values are decreasing. Now, what's the interval? Well, it's going to match the regular domain. Okay, so we can say for x is less than 3, or x is greater than 3, and as an interval, it's negative infinity to 3, union 3 to infinity. Okay, so it's the same as your regular domain. All right, next, end behavior. Let's go ahead and talk end behavior. So what I'm going to do is I'm going to draw this arrow here. Okay, this is going to be my first piece. Okay, and I want to describe this. So where are my x values going? As x is going to negative infinity, so as x approaches negative infinity. All right, what are the y values doing? Well, my y values, okay, my y value here is 0. My y value here is 1. My y value here is getting closer to 2, okay? So f of x approaches 2. That's the asymptote. Now, what part of the asymptote? The top or the bottom? Bottom. There it is. Okay, now I'm going to go ahead and do piece 2. Okay, so where are my x values going? My x value here is 0, x value here is 1, x value here is 2, and it's getting closer and closer to the asymptote, which is at 3. So as x approaches positive 3, and I have to say, okay, what side of the asymptote? The left or the right? Right, this side's the left, this side's the right. Okay, I use a negative for left, I use a positive for right. So 3 from the left. Okay, where are my function values going? F of x is going, my function values are going down to negative infinity. Okay, piece 3, up here. So as x approaches, okay, I want to go towards that arrow. So maybe start from over here, imagine it like this. My x values are going this way. So as x approaches, again, positive 3, but this time from the right. Okay, and my function values this time are going to positive infinity. All right, and then last but not least, here is the fourth piece. As x approaches, okay, and it's going out to the right, well, that is positive infinity. Okay, what are my function values doing? Well, f of x, the function values, my y values, are going towards the top of this asymptote, okay, which is located, again, at 2, right? My y values here, they're 5, 4, 3, okay, and they're going to 2, and 2 from the top or the bottom? The top, so I put a plus. There it is. All right, here's example 2. We'll do this again. Okay, increasing or decreasing? Go. Good job. It's increasing. Right? It's going up. Okay, and then we can say for x is less than negative 4, for x is greater than negative 4. Okay, an interval would be negative infinity to negative 4, union negative 4 to infinity. All right, next, end behavior. So here's piece 1. Okay, again, my x values are going out to the left, so as x approaches negative infinity, all right, what are the y values doing? Well, my y values, f of x, they're approaching the horizontal asymptote, always approaching the horizontal asymptote for the y values at the infinities. Okay, and where is that horizontal asymptote? It's at 0, so it's approaching 0, and from the top or the bottom? From the top, so I put a plus. Okay, a common question we get is, can I do the infinities together? Can I do this endpoint? I like to do my infinities together. Sure, let's do it. As x approaches positive infinity, do I have to put the positive? No, it's up to you. I don't care. Be my guest, be my guest. Put the service, do the test. F of x is also approaching 0. Do you see that? It's also approaching 0, but from the top or the bottom. This time, from the bottom, right? So I put negative, okay? There you go. Hey, Easy. All right. Now I'll do this piece. Here's number 3. Okay, what are my x values doing? So x values are getting closer and closer to this horizontal asymptote. It's like a wall. They're going to get close, but they're never going to touch. Okay, and that's at -4. As x approaches -4, what side of -4? From the left. So I put a little negative there. Okay, my function values, are they going, where are the y values going? Are they going up or going down? They're going up. And today happens to be Monday. Darn, it's not a Tuesday. That would have been a good joke. Do you guys even know that song? I don't know. Next, last piece. Down here. Boop, here's number 4. Okay, so again, my x values, it's approaching the asymptote at -4, but from the left or the right? From the right. Okay, so I put a plus sign there, and then f of x is going down. All right. Okay, here's a practice problem. Here you go. This is you time. Okay, so go ahead and give this one a go. Pause the video. All right, hopefully you pause the video. Here is the answer. I just realized I gave you away the increasing, decreasing. You're welcome. Okay, here is the answers. Check your work. I know end behavior, this one is kind of tough. It takes some practice, and we'll do some work with it, okay? All right, hey, that is it for this video. Whew, it was a long one, but end behavior, not gonna lie, that's tough for us. That's tough. Let's be real. That's tough. Okay, all right, hey, that's it. Peace. I'm out of here.